All right. So we've talked about vertical manipulations and one horizontal manipulation of sinusoids, but there's another way to move a sinusoid. So far, every sinusoid we've had let's say we had one with an axis of the wave at y equals 1, an amplitude of 3, so that means the maximums would be at 4, and the minimums would be at -2. So it's bouncing between 4 and -2. And a period of, let's say 8. All right? So at 8 and -8, it completes a full cycle. And there's 4 quadrants. There's 4 sections of each full cycle to follow our pattern. Now, if it were a sine function, it would start at the axis of the wave. If it were a positive sign, it would go up first. If it were a negative sign, it would go down first. If it were a cosine function, if it's positive, it would start at the maximum. Negative would start at the minimum. But those are the only 3 places we could say it started. But not every sinusoid is necessarily going to start there. What if instead the axis of the wave was at 3? Well, and the period's 8, a quarter of the period is 2. So then you would have a maximum at 5. Then another quarter of the period later, you're back at the axis of the wave. Then another quarter of a period later, you're at a minimum. So axis of the wave at 7, minimum at 9. Going backwards, axis of the wave to minimum. A quarter of a period back brings us to 1. So we're at 1, we're at a minimum. At -1, we're back at the axis of the wave. At -3, we're at a maximum. At -5, we're at the axis of the wave. And -7, we're at a minimum. Well, missed that point, but not going to redo it. There we go. So this would be our curve. But at the y-axis, it's at this arbitrary point. It's not at the axis of the wave. It's not at maximum. It's not at a minimum. This is because there is a horizontal shift. And that horizontal shift is called a phase shift. So let's talk about how an equation would change our phase shift, would give us a phase shift. So our general equation, I'm just going to do a sine equation. It's the same for a cosine equation, but it would just change where your starting value is. So y equals a sine of b x minus h plus k. So everything that we knew before is still the same. Absolute value of a, sorry, the magnitude of a, but I wanted absolute value. Absolute value of a is our amplitude. Two pi over b tells us our period. And y equals k tells us our axis of the wave. So all of that stuff is still true. But then there's this h. So this h is what tells us our phase shift. So the h tells us our phase shift. It's supposed to be minus h. It's supposed to be minus h. If it is plus h, that means h is negative. So it's supposed to be minus h. So if it's minus, h is positive. If h is greater than 0, you're going to the right, because that's the positive direction horizontally. If h is less than 0, you're going to the left. This phase shift tells us how far we shift the whole function. We just pick it up and shift it h units to the right or to the left, depending whether it's positive or negative. All right, so let's take a look at a function. Let's take a look at an arbitrary function. Let's say we had y equals 3 sine of, say, pi over 2, x minus 1, plus 1. So everything from before is the same. The amplitude is a, so the amplitude's 3. The axis of the wave is y equals k, so y equals 1. So that means our maximums will be at 4, our minimums will be at -2. And our period is 2 pi over pi over 2. So that's 2 pi dividing by a fraction is the same as multiplying by the reciprocal. The pi's divide off, leaving us with 4. So our period is 4. So it repeats itself every 4. And now we have the phase shift. So that's the only thing that's new. So our phase shift is 1, and it's minus, so the 1 is positive, so we're going 1 to the right. So that's what it tells us to do. So those are the 4 pieces we get from the graph. From the equation for the graph. There's a couple other pieces that I like to find. I know that it takes 4 units to complete a full cycle, but it's easier if you know when you follow the pattern. Because the full cycle for a sine function, a positive sine, it goes axis maximum, axis minimum, axis. So you have these points in one full cycle. So that's 4 intervals. They each happen 1/4 of a period. So I like to find out what 1/4 of a period is. So in this case, 1/4 of 4 is just 1. So that's going to be 1 unit. That's going to be 1 unit. That's going to be 1 unit. And that's going to be 1 unit. All right. So we have that. And then I also like to figure out where we start. It's a positive sine. Positive sine starts, a positive sine starts at the axis of the wave going up. So regardless whether it's a sine or a cosine function, finding the amplitude is the same, finding the axis of the wave is the same, finding the period of this is the same, and finding the phase shift is the same. Regardless whether it's a sine or a cosine function, the pattern is still going to be happening every 1/4 of a period. But what the sine and cosine changes is where it starts. If it's a positive sine, it starts at the axis of the wave and goes up first. If it's a negative sine, it starts at the axis of the wave and then goes down first. If it's a positive cosine, it starts at the maximum. Negative cosine starts at the minimum. So I'm just going to put this off to the side and let's set up our graph. So our graph, just a standard grid. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 6, 7. 1, 2, 3, 4, 5. All right. So now let's figure out what a good scale would be. For our y-axis, the vertical transformations are the amplitude and the axis of the wave. So our amplitude is 3, our axis of the wave is 1. So we have maximums at 4, minimums at -2. So a scale of just 1 would be a decent scale. 1 would be a decent scale for our y-axis. So I'm just going to sketch in my axis of the wave. You don't need to, but I find it's really helpful. And then our maximums are at 4. I like to just make an extra mark at 4, so I know that nothing's going to go above that. And then our minimums would be at -2. I make a mark at -2, so I know nothing's going to go below that. So our amplitude tells us we're 3 above and 3 below the axis of the wave. So that's all we need for the vertical. For the horizontal, though, our period is 4, and our critical points are every 1. So I'm going to do a scale of 1. So every tick mark, we're going to hit one of our critical points. And that'll be 4. So we should have 1 full cycle between 0 and 4. 1 full cycle between 1 and 5. 1 full cycle between 2 and 6. So on and so forth. And it'll just follow backwards as well. So every tick mark, we're going to hit a critical point. And it's a positive sine function. Positive sine starts at the axis of the wave going up. So if we didn't have a phase shift, we would be starting here. We would be starting at the axis of the wave, and then we would go up, down, down, up, down, up, so on and so forth. Okay, or sorry, I meant to say 2 ups and I messed up. I usually like to say axis maximum, axis minimum, axis maximum, axis minimum, axis maximum, axis minimum, so on and so forth. So usually we start the axis of the wave on the y-axis, but that has been shifted. This is what our phase shift does. It takes that point and it moves it 1 to the right. So normally we will be at the y-axis, at the axis of the wave, but that's moved to the right 1. And this is where we can start our pattern. Axis maximum, axis minimum, axis maximum, axis minimum, and then going backwards, axis minimum, axis maximum, axis minimum, axis maximum, axis minimum. So we get our curve. And that's the graph of this function. So that's what the phase shift does. And those are the only manipulations we're going to work with for sinusoids. So have fun, enjoy.